Okay, what is statistics all about? What's this course all about? Trying to predict the future. Before Election Day this year, polls came out and they were right. They only asked a couple of thousand people, and they figured out exactly how the election was going to come out before it came out. Say we've got this new medication that's going to help cancer patients. Trying to figure out on average how long they're going to live. Obviously we can't give this to every single person out there that could ever have cancer. Okay, we're going to take a sample, and from that sample we're going to predict what it would be like for everybody. How in the world can that little prediction even be close? Okay, that's what we're going to learn about this chapter. Okay, it all revolves around something called the sampling distribution. Okay, so trying to predict the future, that's another word for that is inference. Okay, that's what it's called in statistics. We're trying to predict the future of what's going to happen. And here's the bottom line of it. If we can have an understanding of what a statistic is, okay, so let's get some symbols here and what they mean. A statistic is anything that you take from a sample. Right now, you're taking a sample. You've got 1,800 names. We're trying to figure out the average length of names at Elk Grove High School. You're taking 20 of them, and then from those 20, you're deriving something. In this case, you're deriving the average of those 20, the mean. Okay? That symbol is going to be X bar. That's a symbol that we've used before. Tomorrow, we're going to try to figure out the proportion of girls on campus. Okay, so you're going to take 20 names. Let's say you get 10 girls, and your proportion would be 0.5. Okay, so from that sample of 20, if we're calculating something from a sample of 20, it's proportion. This is new for you. This is going to be called p hat. So you're going to say p hat equals something tomorrow when you calculate that proportion. Okay? And if you take a sample, how big your sample is, that's going to be small letter n. So in what you're doing right now, you're grabbing those 20 names, small n is going to be equal to 20. But what we're really trying to figure out is, how far is my statistic going to be from the right answer? Now the right answer is what the answer is for the entire population. We have 1,800 names in there. If we took all 1,800 names and found the average length of the name, that symbol would be nu. Okay? When we take all 1,800 students and find out the percentage of them that are girl, that's going to be capital P now. So the statistic is p hat. The parameter would be capital P. And then all of the elements of the population, how many there are, that's going to be capital N. That's how many are in that bowl right now, 1,800. For the election day, what was capital N? Millions and millions and millions of people who voted, right? What's capital N for this new drug for cancer patients? Well, it could be everybody that could ever have cancer. From here on out, it's almost infinite. Okay? So those are the symbols that we're going to use for that. So parameter is a number that we derive from the population. A statistic, which is what you're doing right now. You're calculating a statistic, comes from a sample. And those are the symbols we're going to use for that. But the bottom line is, how far away is this guy going to be from this guy? If we know that the statistic's going to be super close to this, then we can go on television and brag about it. Hey, I've got the answer. But if we're not so sure that this is going to be very close to what we're predicting, we ain't going on television. We're going to hide in a hole someplace. We're not going to try to predict anything. And it all comes down to this. It's called the sampling variability. How spread out are those statistics that you can get? For example, let's say you just got the mean of your 20 and the average length of names was 6. Your average length of names was 100. Yours was 1,000. Yours was 5. You get the idea? There's great variability in the different samples that you can get. Are any of you going to have confidence to go on television and say you've got the right answer if those are the possibilities that you could get? No. Wouldn't have any confidence at all. But, I don't know, let's say you got 13.1 and you got 13 and you got 13.05 and you got 13.1. Are you thinking then that maybe your sample mean might be really close to the right answer? And the answer is yeah. So if we can kind of figure out how spread out all of the possibilities of them are, what is the sampling variability, how spread out the different statistics, how far off the different sample means are from each other, if we can figure that out, then we may have some confidence. And that's exactly what we're going to do. You ever see on television they say, okay, Obama's going to get this percentage of the vote, but on the bottom, they say with a sampling error of like 3%, they know about how close their statistic, their sample was. And that's what we're going to learn about this chapter. There's a big fancy name for it, just don't even worry about this, but the sampling variability is the standard deviation of all the possible sample statistics. What? Okay, that's what we're going to talk about. We're going to figure out what that is. All right, this is the big boy right here. It's called the sampling distribution. The sampling distribution is defined as every possible sample mean that you could get. You got one, right? You got an X bar, right? You got a different one, didn't you? You got a different one. You got a different one. They took a different combination of those 20 names out, and then they went and got their X bar. Today in class, we're going to get about 35 different X bars. Well, how many do you think different X bars are possible to be out there? Well, if we've got 1,800 students, how many different combinations of 20 names can we get? Somebody want to throw that in their calculator? I don't know if it's going to blow up or start burning, or calculator's even going to work for that. I mean, what is that? Overflow, maybe? I don't know. Try it. That's a combination key. Remember NCR? We talked about last chapter. Anybody got it yet?
4.713.
4.7, and then how e to the what? 46. Move that guy 46 places and start adding some zeros. Remember how I said this thing's kind of blow your mindish? That's how many different X bars would go into that thing called the sampling distribution. This guy's got that many different X bars. That's what a sampling distribution is. But what if all of these X bars are right next to each other? What if all these X bars are all crazy different than each other? Now remember, we're only going to have one of these guys. Let me try to explain this. Let's go back to this picture here. Okay, turn this around. And I'm hoping this kind of explains what the sampling distribution is. I've done this for years. My classes hate them. I think it's brilliant. I don't know. But you guys are going to hate it. But just stay with me here, okay? Red for reality. Red is this population distribution. If I look in there, let's pretend like this is the thing I'm looking in, there's 1,800 different names in there, and all of which have a link to it. You know, those are the links of the names you see in there. So this is the population in our little problem that we're doing right now. If this is for voters, this is all the voters in the whole country. Okay. Now this is what we're trying to figure out. This is our goal. What's the mean of all those 1,800 links of names? I have no idea what that is, but that's our goal. That's what we're trying to figure out. And I wonder how spread out all those names are from each other, the standard deviation. Now remember, if it's the population, that's the standard deviation that we use. Okay, in your calculator, remember those are two different standard deviations. But again, we have no idea what this is. Nor do we know what shape this has. Those 1,800 names, I guess I could take all 1,800 of them out, get them in L1 or whatever, and then make a graph of them, but I have no idea what the shape of that's going to be. Okay? All right, the middle one. That's what you guys are doing right now. Keep it moving. Keep it going. We got to get over there. That's what you're doing right now. You're taking 20 names out, and we're analyzing it. Okay? Got to get the right color. Blue, I got to have blue. That's part of the charm of this. Color coded. Blue. Madison, did you get a mean for your 20 numbers?
Yes. I got 13.2.
Okay, 13.2. Did you get a sample standard deviation?
I got 3.47.
Okay, so that's how spread out her 20 numbers are, on average from 13.2. And did you get a shape here, roughly? What would you say that is? Unimodal, bimodal, skewed right, skewed left? Somebody else got one? What do you get? You got one?
I got unimodal, skewed right.
Yeah, maybe a little modal. You just got, I don't know, it's your 20, right? And actually, I think this one kind of makes sense, doesn't it? Don't some people have some crazy long names? Right? Since then most of the names are kind of in here, but we got some crazy long ones. So unimodal, skewed right, kind of makes a little bit of sense. I don't know. Different distributions could be different. But this is what you're doing. And this is the point I'm trying to make that you need to understand. Madison, you're going on TV with that. You're saying that the whole school, the average for the whole school is 13.2. Now, do you think you're exactly right? Probably not, right? I mean, you only took 20 of them. All 1,800 of them being 13.2, but I wonder how close she is. Okay, that's our goal. Well, to get an idea of how close she is, we're going to study this. And this is what we're studying in this chapter. One of the elements up here is 13.2. That's Madison's mean. Then you're getting another one. You're getting another one. You're getting another one. We're going to have, out of this class, about 35 of them in here. Of the 4 with 47 zeros. That's how many there are. Okay, but we're going to study what this thing is like, and what we're going to look at is, I wonder what the center of all these x bars is. I wonder what the mean of all these means. Wow, it's already getting weird, right? I'm going to try to find the mean of all these means. I wonder what that is. I wonder how spread out. And that's what sampling variability is. How spread out are all these x bars? You guys told me if they're all really bunched together, then I'm going to feel good about going on television with this guy. If they're all crazy different, I'm going to be scared to go on television. It could be really wrong. Okay? And then finally, we're going to spend a lot of time on what's the shape of this thing going to be. I wonder what shape it's ultimately going to have. Okay? So this is the sampling distribution. Okay? This is what we're going to be focused on and learning. Any questions, comments? Okay, let's go. All right, let's talk about